SpaceX is at the top of its game, and it doesn't look like things are going to change anytime soon. Elon Musk's next plan could be to revolutionize manufacturing in space. So, Varda Space Industries, a startup that wants to build in-space manufacturing facilities, will be sending its first spacecraft to orbit aboard a Falcon 9 rocket in 2023. The spacecraft will spend up to 3 months in orbit to test space manufacturing technologies. At the end of that mission, a re-entry capsule will return about 40 to 60 kilograms of materials produced in orbit to Earth. According to Varda executives, the company chose SpaceX because it offered the cheapest and most reliable solution for getting their spacecraft to orbit. Delian Asparov, co-founder and president of Varda Space, pointed out that launch costs are a key driver of the young company's economics, which does explain their choice to stick to the cheapest available solution. Asparov also shared his sentiments about the new deal, saying, "We are excited for Varda's signing with SpaceX as its launch provider. The massive reduction in barriers to entry will allow Varda to finally bring the enormous benefits of space through microgravity manufacturing to so many people on Earth, whose lives will change tangibly for the better as a result." Another reason why Varda must have picked SpaceX is that both Varda Space Industry founders are very familiar with Elon Musk's company. Will Brewy worked for nearly 6 years at SpaceX, while Delian Asparov is a principal at Founders Fund, which has investments in both Varda Space and SpaceX. Just 5 years ago, the existence of a company like Varda would have been impossible. But today, the company is not only up and running, it's also in a position to economically deliver unique products that can only be manufactured in space, all thanks to cheaper launches, better regulations, and commoditized space hardware solutions. Since prolonged exposure to zero gravity is not possible on Earth, Brewy is excited by the idea of using Varda's expertise in space to bring interesting possibilities to Earth's largest industries. Now, let's address the million-dollar question. What the heck can you make in space that you can't on Earth? Certain items like specialized semiconductors, bioprinted human organs, and Z-band, which is a super efficient fiber optic cable, can only be efficiently made in microgravity. And space is the only place microgravity is found for sustained periods. Varda Space is a year-old startup with aspirations larger than most corporate giants. Its mission is to build the world's first space factory, or to be more specific, the first all-in-one space factory. The title of First Space Factory should really go to the ISS, since it routinely hosts payloads from paying customers, some of which are focused on manufacturing materials that can only be made in microgravity. It should be noted that the volumes produced by these experiments are absurdly low, which is a problem Varda Space plans to fix. The products that these ISS mini-factories produce are then returned to Earth on one of SpaceX's Dragons, which to this day is still the only spacecraft in existence capable of delivering large amounts of cargo from space to Earth more than a decade after its debut. We have established that orbital manufacturing has been going on for years, albeit at a very small scale. So now, let's see what the new startup from California aims to do differently. The game plan for Varda Space is simple: to repeat and expand on the International Space Station's proven model, forging a pathway to commercialization, as opposed to launching mini-factories with small experiments to the ISS, of which the crew on board is practically forced to troubleshoot and maintain. Varda wants to build its own small satellites with tiny re-entry capsules, capable of returning up to 100 kilograms or 220 pounds to Earth. Despite being launched on a Falcon 9 by SpaceX, the actual spacecraft for the 2023 mission will be made by Rocket Lab. Varda revealed that it had purchased 3 of Rocket Lab's Photon satellite buses, which would serve as a sort of mothership for each Varda-built re-entry capsule. Photon is based on Rocket Lab's successful Electron rocket kick stage and adds avionics, batteries, more propellant, solar panels, and optional propulsion upgrades to create an off-the-shelf satellite bus capable of supporting and powering onboard payloads. This means that Photon gives customers the opportunity to focus their time and resources on developing the payloads they want to deploy and services they want to operate, rather than having to build and qualify their own satellites. Varda Space seems to be the first company intent on taking full advantage of that, but many more are certain to follow. We should mention that Varda Space effectively revealed that Rocket Lab has no clause preventing Photon customers from launching the satellite buses they buy on rockets not built by Rocket Lab, which does explain the SpaceX launch contract. Some dedicated small satellite launchers like Rocket Lab's Electron offer some benefits, but their rates are usually very high. While an Electron launch carrying 440 pounds to to a sun-synchronous orbit is believed to cost around $7.5 million. A slot on a SpaceX rideshare to a similar but not as perfectly tailored orbit would cost the same customer around $1 million. Rocket Lab's Photon costs a few $1,000,000 and comes with a propulsion system capable of refining the spacecraft's orbit after the rideshare launch. Varda's customized Photon will be one of the many objects aboard Falcon 9's rideshare mission, a new and lucrative program that spreads the cost of going to space between customers by allowing them to basically carpool to space. SpaceX promises to slash the cost of launch to as low as $1 million for an individual customer looking to send up to 440 pounds of payload to sun-synchronous orbit. Yikes. Good luck to any company trying to compete with that. Unlike communications and imaging spacecraft, Varda doesn't need a specific orbit for its mission beyond remaining in low Earth orbit, which makes it ideal for rideshare launches. According to Brewy, the only thing that matters will be making sure that the orbital inclination is high enough to go over Varda's landing site. The re-entry capsule will land at a location that Varda Space has yet to disclose. Brewy says the key to success is putting working hardware in orbit quickly, and judging by how quickly his company has been working, he believes it. In July, Varda announced a $42 million Series A round led by Kozla Ventures and Caffeinated Capital. The Torrance, a California-based startup, has raised more than $53 million to date, which is a jaw-dropping figure considering that the company was founded in November 2020. Even though Varda has mentioned a range of high-value products including optical fiber and pharmaceuticals, we still don't know exactly what it intends to manufacture in space. When asked, company co-founder and president Asparuhov refused to disclose the first material they would produce in space, saying that the company would announce it once it signed a contract with a customer. He also said that there was a 50% chance that could happen in the next 6 months. According to Asparuhov, Varda is working on the technologies needed for space manufacturing that he said will give it a competitive advantage. But at the moment, their biggest challenge by far is developing the re-entry capsule that will return the materials to Earth. Brewy highlighted this, saying, "Strictly speaking, re-entry is harder than any manufacturing hardware apparatus. Hitting the atmosphere at Mach 28 is the hardest problem. Besides creating niche products, manufacturing in space could offer a unique advantage to certain companies due to its low pressure, which lowers the chance of contamination. This would save a ton of money for companies with complex decontamination systems." On its website, SpaceForge, a UK-based space company, said that manufacturing on Earth has several challenges to overcome. The biggest challenge is gravity, which causes buoyancy, preventing the formation of perfect alloys in metals of different densities, while Earth's dense ambient atmosphere contaminates even the cleanest of processes. Maintaining extreme temperatures is also very hard to do on Earth, all the way from cryogenic refrigerators to furnaces. It is much easier to do in the vacuum of space, since heat and cold can't escape into the surrounding air as they do on Earth. Obviously, despite having a number of perks, in-space manufacturing still faces a few challenges. For one, processes and equipment are likely to be exposed to high levels of radiation, and they must be able to withstand exposure to solar flares. They may also be exposed to extreme temperatures, both hot and cold. When in orbit, it can be difficult to control systems and process machinery in real time from Earth. But despite all of these challenges, multiple space companies and agencies are still interested. Yup, even in its early days, Varda is already facing stiff competition. For example, SpaceForge is developing fully returnable satellites that are designed for manufacturing next-generation supermaterials in space. In creating a reliable return mechanism, SpaceForge aims to advance the expansion of the microgravity market for premium research and development applications by lowering barriers to entry. As he was commenting on the commercial opportunity presented by in-space manufacturing, Joshua Western, the SpaceForge CEO, basically echoed Brewy, saying, "There are huge opportunities for in-space manufacture enabling us to make space work for humanity, but currently, key barriers exist, namely, no dedicated platform and no soft return. The key to commercial in-space manufacture is accurate, manageable return." NASA is also dipping its toes into this very attractive pond by attempting to demonstrate 3D printing technology in space using regolith simulating feedstock material, which in layman's terms means using simulated lunar soil. In the future, this could allow colonists on the Moon and Mars to produce some of their own habitats and reduce the need to take large volumes of construction materials into space. So after its huge launch deal with SpaceX, will Varda dominate the in-space manufacturing market? Only time will tell. When do you think in-space manufacturing will become a space industry standard? Let us know what you think and more down in the comments below. Don't forget to like the video and subscribe to our channel if you haven't already. for all the coolest tech news, events, stories, and product releases. Until next time, welcome to the future.